Good morning, students. Today we will discuss the preparation of phenol. We have completed the preparation of alcohol and the isomerism which is observed in the alcohol. Right? So today our topic is preparation of phenol. Now students, phenol is also known as carbolic acid. It can be prepared from the benzene sulfonic acid, right? The first preparation that we will discuss here is the preparation of benzene sulfonic acid from benzene sulfonic acid. So the first preparation is from benzene sulfonic acid. So student, we will take the sodium salt of benzene sulfonic acid. Benzene sulfonic acid is what? It is SO3H. So we are taking the sodium salt of benzene sulfonic acid. Right? Now, you can prepare it when the benzene sulfonic acid will react with a base NaOH. Right? We will get the sodium salt of it and water will be released. Now, next we will get it reacted it with NaOH, right? And we will obtain this will be Na2SO3. That part will get removed and student we will get sodium phenoxide at first step. Now this phenoxide, sodium phenoxide, at the acidification with dilute HCl will give us phenol, right? And NaCl is the side product which will be obtained. Students, second preparation is from the benzene diazonium chloride. Here, when benzene diazonium chloride is warmed with water, right, we obtain phenol. Along with that, N2 and HCl are the side products which are obtained. Third, we can prepare phenol from the chlorobenzene, right? So next is from the, okay, before we start with the from the chlorobenzene, let's from decarboxylation of sodium salicylate. Sodium salicylate. So we have salicylic acid. This is sodium salt of it, right? So we will carry out, students, decarboxylation, right? So we have got this sodium salicylate with benzene ring. We have OH and COONA. We will get it decarboxylated by mixture of soda lime, NaOH, and calcium oxide. Heating this mixture, soda lime, 3:1 part of NaOH and calcium oxide. We will obtain here sodium phenoxide. This is minus Na2CO3, and this on treatment with or simple acidification with dilute HCl will give us phenol. Right? So we can prepare the phenol from the decarboxylation of sodium salicylate. In the same way, students, we can obtain the phenol from the chlorobenzene also, right? And for that, we will just get the mixture treated with, okay, space here, I'm just writing this is from chlorobenzene, right? Get it treated with NaOH at 623 Kelvin and 300 atm pressure. This reaction we have discussed as a chemical property of haloarenes. So we will obtain here sodium phenoxide, which further on treatment with dilute HCl will give us phenol will be obtained. Right? So the phenol can be obtained from the chlorobenzene also. Now next preparation is from the isopropyl benzene, that is also known as cumin. Right? So next is from cumin, that is known as isopropyl benzene. So this is benzene isopropyl. Now when we carry out the process, or when the cumin is heated in the blast of air, right, we get cumin hydroxide formed. This is there CO and this is CH3 here. This is cumin peroxide which is formed. Right? Now this cumin peroxide, right, gets decomposed to phenol and acetone. Right? So cumin peroxide will give us phenol and acetone will be formed. This is the we can say one of the preparation of the phenol. So cumin will on oxidation with air will give us cumin, which is student hydro peroxide, which from which we can obtain the phenol and acetone by the acid hydrolysis of water, or just acid on getting it acidified with an acid. Right? So these are the main preparation of phenol. Now students, we are going to discuss the physical properties of alcohol and phenol. Okay, now the students, alcohol, the lower alcohols are colorless, liquid with burning taste, whereas higher alcohols right, they are waxy solid, colorless waxy solid, right? So the lower alcohols means methanol, ethanol, propanol. You know that they are the colorless, they are in liquid state, right? And they have got a very particular characteristic smell or pungent a smell is there with a burning taste, right? Whereas the higher alcohols, they are colorless, waxy, solid. That is about the high alcohol. Now student, next come the solubility. Now you know that the alcohol has got, along with the alcohol, along with the alkyl group, we have got a hydroxy group. So they form hydrogen bonding, intermolecular hydrogen bonding with water, and hence they are soluble in water. So they are soluble in water due to intermolecular hydrogen bond. Right. So if this is here OH, right? So we are showing this is the water molecule. So there is a intermolecular association between the alcohol and the water. So hence they are soluble in water. Now let me here add in that with increasing alkyl group, student, with increase in size of alkyl group, that is R, solubility will decrease. Right? So if student, the alkyl group R, that is if it increases in size, right? So there will be student decrease in the solubility of the, or we can say decrease in the magnitude of the extent of intermolecular hydrogen bonding, right? And hence the solubility will decrease with increase in the size of the alkyl group, right, in the alcohol. Now next, student, is the boiling point. Now boiling point, here it is a bulk property, right? So here, since intermolecular hydrogen bond is formed between alcohol molecule, therefore has high boiling point, right? Therefore has high boiling point. Now here, let's see the how the hydrogen bond is going to be formed here. So this is, if it is ROH, I'm showing this is ROH. This bond is there. Now this is ROH, another alcohol molecule. Again, we have this one, another alcohol molecule. So you can see that the intermolecular hydrogen bonding is getting formed between the alcohol molecule. Therefore, there will be strong interaction and hence the boiling point is going to be high. Right. Now one more thing to be added here, that if it is isomeric alcohol, student, that means if it is primary, secondary and tertiary alcohol, if we compare primary, secondary and tertiary alcohol, the boiling point of the primary alcohol will be more, right? So here the primary alcohol will have higher boiling point. Now why it is so? Because the another force that is going to work here is the van der Waals forces, and which depends upon the surface area. Now if it is CH3, CH2O, it is the primary alcohol, and if we take a secondary alcohol here, student, this is the secondary alcohol here. So, and another we can take the tertiary alcohol. So where we are having the greater surface area, right? The surface area, okay, let me get it, of same equivalent carbon atom. So we are having here how much? 3. Okay, so it is here butyl alcohol. Now let me increase the chain here and let it be CH2OH. Now we have in total all have got N equals to 4 butane, right? But this is the primary alcohol, this is secondary and this is tertiary. Where do we have greater surface area? It's a greater surface area here. So the van der Waals forces will be high in case of the primary alcohol, and hence greater force of interaction will be observed in the primary alcohol. Therefore, the boiling point will be more of the primary alcohol, right? So, the boiling point will first depend on the extent of the hydrogen bonding, intermolecular hydrogen bonding, and for the isomeric alcohol, students, you will apply the concept of the van der Waals forces right, which in turn depend upon the surface area. Now students, we will discuss the physical properties of phenol. Generally the phenol, simple phenols are colorless liquids or solids, right, and the color changes to pink or red on exposure, or we can say on standing. On standing, that means if we keep the phenol, if the phenol is kept for a long time, right, it will get changed to pink or red in color. Otherwise it is colorless, and if it is opened in air, it will easily get reacted with the air. Now the solubility, students, they are generally less soluble in water, but will get dissolved in the organic solvent and even in the sodium hydroxide also. Generally less soluble in water, which is because of big size hydrocarbon part. And which hydrocarbon part, student? It is the aromatic ring. Now coming to the boiling point, they have high boiling point because of intermolecular hydrogen bond between the molecules. So if you take an example here, let it be, this is phenol here, right? So here another phenol molecule, it is going to form intermolecular hydrogen bonding in this way, right? As a result, the stronger force of interaction and the boiling point will get increased, right? So students, we have discussed here today the preparation of phenol and the physical properties of alcohol and phenol, right? So next we are going to discuss the chemical properties of alcohol and phenol, right, in our next class. Thank you.